Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at the inclusion-exclusion principle. This is a way to help us count the number of elements that are in sets. So you probably already know the inclusion-exclusion principle for two sets. It's written here. So I'll show you in a Venn diagram. If I want to find the number in A or B, remember that's everything inside the circles. What I can do is I can take the number that are in A, which is this here. Then I can take the number in B, which is this number here. But notice that I've double counted what's in the center, A and B. A and B is this middle part here. So the reason I have to subtract it is because it's been double counted. So you probably already know that one, but let's look at what it is, the inclusion-exclusion principle for three sets, A, B, and C. So we start off by adding the elements that are in at least one set. So on our Venn diagram, that includes ones that are written at any of these spots. So that's A plus B plus C, which includes all these ones here. So then what we do is we subtract those that are in at least two sets. So we're going to take away all the ones that are in A and B, so that includes the ones that are here and also here. Then we're going to subtract the ones in A and C, so we're going to subtract one of those and one of those, and then we're going to subtract those that are in B and C. So you can see a problem here. I've counted every possibility exactly once, which is good, but I haven't counted those that are in the center. So in order to make this formula work, I'm going to need to add those elements that are in all three sets. That'll bring a tick back here, and you can see I've counted all of the possibilities. So remember, A or B or C is everything inside these three circles. So let's look at solving some problems using this principle. So here we have a question involving three sets. We've got the number of people play AFL, I'll call that set A, the number who play basketball, set B, and the number who play cricket as set C. We're asked how many people play none of these sports. Now note that this formula here, the inclusion-exclusion principle, it tells us how many are inside the circle. It tells us how many are in this yellow bit here. But the question asked us to find how many people don't play any of the sports, this green bit here. So what we'll do is we'll use the inclusion-exclusion principle to count how many are inside the circles and then subtract from 200. So just a note, this is quite an easy question for which you could draw a three-way Venn diagram and fill it in with numbers, but you won't always be able to do that. So let's get used to using this formula. Now, if you have more than three sets, it becomes extremely complicated just to draw the Venn diagram, let alone fill it up with numbers. So the inclusion-exclusion principle says the number that play at least one sport, AFL or basketball or cricket, is equal to all of these. This question's easy because each of these numbers is laid out for us nicely. So to find the number that play at least one sport, we'll take the numbers that play each of the individual sports and add them. Then we're going to subtract those that play multiple sports. So A and B, we were told was 9, and then 14, and then 5. And then we have to add the number that play all three. So you can use your calculator if you like. That gives us 77. That tells us 77 different people play at least one sport. Therefore, the other 123 play none of these sports. All right, let's now look at a harder question. So here we're told a college has 150 students. Every student must study maths, English or science. 120 study maths, 100 English, 80 science, 70 or 3. How many study exactly two subjects? Let's use the inclusion-exclusion principle. So this is the inclusion-exclusion principle applied to this question. Now, this is the number that study at least one subject. But if everyone at the college, if all 150 students have to study at least one subject, that'll be 150. Okay, so that equals the number that study each of the individual subjects added together. So 120 plus 100 plus 80. Now, we don't know what any of these are, so we'll leave them for now. And then finally, we add the 70 that study all three subjects. So now we're going to subtract each of these numbers from both sides of the equation. So we get minus 220 is equal to these numbers here. So I can multiply each side of the equation by -1. That just changes the sign of each of the individual terms. So what we have here is that 220 students study both maths and English, or maths and science, or English and science. But our final answer can't be 220. If there's only 150 students at the college, we can't have 220 studying exactly two subjects. So how does it work? Well, this 220, what we're saying here is it includes this number here, the number that are here, plus the number that are here, plus the number that are here. You can see that I have included this middle bit 3 times. The number that study exactly two subjects are these people, and these people. But I added this 3 times, so I'm going to need to subtract 3 lots of it to leave these 3. So the number who study exactly 2 is these 220 minus 3 lots of the students who study all 3. There are 10. So that means that the 3 numbers that go here add up to 10. It doesn't tell us individually what these numbers are, and that's why this is an example of a question where you can't just draw a 3-way Venn diagram and stick in all the numbers. We need our inclusion-exclusion principle. By all means, you can draw a Venn diagram to kind of see what's going on, but we can't rely on filling in all of these numbers because we didn't know them in this question. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.